Okay. So, so we know already what is RL, I mean reinforcement learning, what kind of AI techniques and algorithm it is just involving in to make decisions in an environment in order to maximize a reward. So it always going towards a reward, not on the punishable thing. I mean, not on the punished things. That means we need to increase the value of the positivity, the positive side, so that if you just keep on increasing the positive side, it will get rewarded, and the accuracy is getting more and more and more. You get closer to the 100%. I mean, not 100%. I mean, that is what they aim, but it is still the point of learning curve or the training curve is always should be there when it is getting rewarded. So winning the game, always it's on the positive side. So losing the game, it's always is on the negative side. But the beauty of this reinforcement learning, whenever it is going towards the negative side, it is trying to learn more and more, and then it is come back with the more potential. Okay, so that is another side of reinforcement learning. But not only winning the game is always the there, but it is also learning its own mistakes. So that is why a lot of reinforcement model, it is initially it is just based on the learning curve. After that, the model will get picked up. So when Google Gemini was introduced, like BARD, the bot tool, the response was uh, very annoying, very irritating. If you ask them something, it will give the response something which is unnecessary towards the question. Okay. So it got very negative feedback, and then they stopped, and then they again they just released the another version for the public, and from that point onwards, the model is getting trained on a lot of things. So that is also one of the key factor why it is getting giving a negative response initially. Maybe the mapping would not be fixed. We never know what is happening for any kind of thing. But um, uh, it is not only for Google; for anyone it can happen. So the same thing can happen for Google itself, right? So they are not from some other space. Right? They are also a human being. It doesn't matter with the money or something. So anyway, you are just playing with playing around data. It has to speak the correct or the right the model. So that was the key problem, and they just corrected it. One of the key factor is still it is getting. I mean, it was getting the negative kind of feedback. That means the reinforcement learning was there behind it, and now it is okay. It is not that bad. I mean, it is giving a lot out. The APIs are working like anything. A lot of enterprises they are using that Google Gemini application. So it is also, if you just compare with comparison of OpenAI, Google Gemini, and also Perplexity, the other Cloud, if you just take the responses, and always Gemini would be the second place. Because the response almost okay, kind of. It is not too bad. So yeah, that is also based on the reinforcement learning. Okay. So the thing. mm, I think this is based on context. Okay. So in the example of playing slot machine games at a casino, again, they are taking the same kind of data, same kind of a game. So the agent, a person playing the game, can use reinforcement learning to predict which machine is most likely to win based on past data. I mean, even if you can see in our fun city or any other gaming, the malls, the gaming environment, you could have seen some of the machines people never touch. Have you seen? Or that machine is just, maybe, it was appearing okay, but people never approach that machine because people, continuously people will be telling to other people or subsequent person, okay, this machine is not responding properly and you can't win this game. So those machines, never people never go and touch that machine. Okay, so you could have seen maybe, if you are just approaching along with your kid, just, test it next time. So agent is trained to make decisions which machine to play that lead to the highest reward, right? The agent receives a reward if it makes a good decision and a penalty if it makes a poor decision. Okay. So through reinforcement model or learning, the agent can learn which actions are most likely to lead to a successful outcome and make decisions accordingly. So this is the implementation process, how this algorithm is going to work. The goal is to maximize the total reward by choosing the machine that is most likely to win. So the code first initializes the number of machines, an empty list to store the machines that are selected, and list to store the rewards and penalties for each machine. Okay, so let's see this code. See, they are just, going with the random selections. Okay. Yes, NumPy, random pandas, matplot for visualization, the same thing. And we are taking the data, the random value. Let's finish this first. Okay. The second point, if it then loops through the rows of a data table, which presumably contain information about the outcomes of past games. So it just reads all the historical information first, and it just, accumulate those information. Based on that accumulation of past or historical data, it is, trying to give you or assure you what the futuristic or the prediction it might be working on. For each row, the code selects the machine with the highest value of a random generated using the beta distribution, which is determined by the number of rewards and penalties that the machine has received. So while reading the data set or information or past historical data, it is just, getting all the rewards and also the penalties as well. The selected machine is then played and the reward or penalty for the game is recorded. Again, we are just, going and recording along with the past or historical data. Finally, the total reward for each mission is calculated as a sum of its rewards and penalties, and a histogram of the number of times each mission was selected to play is plotted. The same kind of an approach, it is not going to change. I mean, the algorithm or steps is not going to change. Only the method from mathematical approach to random method. That is the only thing has been changed to identify the reinforcement learning process. That's it. So all the four, fifth, I mean 5 points for the steps which is involved over here. It is for in general for UCB or Thompson. So it is the generic process. So if you just, allotted this, maybe you can try in your system too. Okay. I will just extend out this code. You can copy and paste your collab environment. You can just get it. So mission number 1 gained 0 total rewards. Mission 2 gained 0. 3 gained 195 total rewards. 4 gained 0 total rewards, and 5 gained 0 total rewards. So only the mission number 3 is getting the total number of rewards based on the previous one, based on the current one. So how it is getting? Okay. So while you are doing the program, we'll just, see. Before that, we'll see the inferences. Okay. So the above output clearly explains to us that machine 2 was selected every time we ran the code based on the data set we generated. Actually, this is a typo. So you can use any data set to implement the same algorithm. So actually, the number 3, because machine number 2 gained 0 total rewards, and machine number 3 is gained 195 total rewards. Explains to us the machine 2 was selected every time. Let's check it out with with our explanation. So we'll see. So a general idea will come to anyone's mind who will look at the. Actually, it is very simple. Random dot beta variate, that means alpha comma beta. Beta is a function that returns a random float from a beta distribution with shape parameters like alpha and beta. The beta distribution is a continuous probability distribution. It is not a categorical probability distribution. It is a continuous probability distribution. That means numerical information. Okay. So continuous probability distribution defined over the interval 0 or 1. It is often used to model the probability of success in Bernoulli trial, where success is defined as an event with probability where P is occurring. So in your clinical trials, many times you are finding out the P value based on the requirement of your table, listing, figure, or whatever. Even for the analysis data set, you are finding out the probability value. The same kind of an approach we are also applying. The shape of the beta distribution is determined by the value of alpha and beta, which correspond to the number of successes and failures respectively. If it is success, that is an alpha. If it is a failure, it is a beta. So beta is always, it's a testing purpose only. So that is why every product is coming for the new environment. They are just starting to release, and before going to the general public, that application they will be calling it as beta version. Because many products, we can say, even Bard was in a beta version. ChatGPT was in beta version. Now they have just introduced a lot of models. Still, the model is just upcoming. Some versions, because the subscribers are more, so they will be releasing maybe very particular group of people, so that they can get the input. I mean, they can get the input, more input from them. So the beta is always testing. So whatever the failure is occurring, it is getting recorded in beta. The alpha is always for a successful. So this is called as a Bernoulli's trials. Yes, a larger number of value of alpha will result in a peakier distribution with a higher probability of success, while a larger value of beta will result in a flatter distribution with a lower probability of success. So if you see this beta variate function, you can see the number of 0, the probability distribution with respect to this number of occurrences. This here random.beta variate function is being used to generate a random number for each machine based on its past rewards and penalties. The machine with the highest random number is then selected to play. So even for selecting a game, we are not going and choosing manually. There is a process. Based on the random process, the random number has been assigned, and then that random number is then that machine has been selected to play. So this is a common strategy in a multi-armed bandit problem. Yesterday also we have seen the same kind of a situation for multi-armed bandit problem on reinforcement learning, that is on UCB. So we just consider only the upper confidence interval. Whatever the value we are getting, we are just trying to get the maximum value. So here it is a random value. We are just assigning the random thing, and we are just measuring only the success and failures by applying alpha and beta. We are just taking and counting, and based on that success and failure, we have been selected to play that mission. That's it. So where the goal is to balance exploration, trying new machines with exploitation using the best performing machine. I think somewhat, maybe human readable information. Right. So yesterday we have seen about the exploration and exploitation in UCB as well. So with respect to our alpha and beta, where the goal is to balance the exploration with exploitation. So exploration is nothing but you are trying with new missions by giving it a try, on a random order. With exploitation, maybe that mission, if it is, very, very high performing mission or best performing mission, we will be able to choose. So this is what is happening. So just copy and paste this, and we'll just we'll just break down each and every line of code, and then we'll be. I will stop share over here.
From Medium, you have taken, right?
Yes, I have sent you the chat. That link.
Yeah.
Medium is not.
Yeah, I've sent it to chat.
No, medium.com. So currently I'm using what is that? Company laptop. So you are also using company laptop.
No, I'm on my happy laptop.
Then okay, then we can share it. Yeah.
Can share one. Okay, you want me to copy this?
Yeah, copy that code. Yes. Already we have one code. Maybe you can later take a look at it, because I want to take a different one. That's why I choose.
This is an image, yeah.
Okay. There is. You can copy this, yeah.
This is not required any raw data set because you are using random application.
Yes.
Directly.
Yeah. Even if you see just started looking at very closely the reinforcement learning.
New notebook.
There will be no training. Right?
Yeah, no training at all. Directly.
Yes. Yeah. That is
supervised. There is no supervised approach.
Yes.
This is totally unsupervised model. Reinforcement and everything.
Yes. That is another thing.
Okay. Oh, we cannot execute this piece by piece.
No, you have, you have to execute entire. You can do that. You can do that piece by piece. Yeah, you can select only the import, and then you can select data.
We can only select that piece and run, right?
Yes, you can. Just
like this.
go with the import.
Start with the import, all the import libraries.
It will execute only this piece, right?
Yes. No, start with the import. Your screen is not moving. Is he joining?
Yeah.
Sorry, am I audible now?
Yes.
Yes, you are.
What happened to my internet? Yes. So I can run only this piece, right?
Yes,
Yeah,
yes.
till import, yeah. Error.
Selected is equal to J. Oh, it has gone down. See here.
Okay. Name row is not.
It is running complete block.
Let me do one thing.
Maybe you can.
Put it in the next window and copy one by one. Yeah. Next tab.
This piece got executed. No.
So data is part of next one.
This one?
Mm.
Yes.
I think this is continuous till here. Data
Test
machine.
Yeah, yeah.
Test it.
Yeah.
Test it and then
Yeah. So here they are creating a dictionary.
So they have created using the random function for some range value 100, 0, 1. The main 100, 200 range. B1, B2, B3, B4, B5. So 5 column. They created the range of 200 maximum. Enumerate to iterate. So this enumeration is happening for n in range 0 length of data.
Correspond to current actions in every involvement learning. This piece we should run till here. So I'm assuming from here it's a different piece.
Now till that before PLT, the plot histogram it will go. That is the one piece. Now before don't remove that. This for I the loop also you have to copy that. After penalty, just copy that for I in. Yeah, that is also under the same. Yes, we'll move on to place it down total reward. Yeah. This is one piece. Just run this.
Here is the problem.
Reward equal to row selected. Reward equal to selected equal to J. Name row is not defined. Row dot selected.
1 minute. Let us ask Gemini to fix this.
yeah, just okay.
penalties, reward plus penalties.
Not coming.
That means maximum. That is the maximum. You just copy that and put it in the Gemini separately.
And then we can put in Claude only, no?
Hmm. Fix the error.
Okay, I'll help you fix this and improve this code and appears to be implemented a multi-armed bandit algorithm using Thompson sampling. Here's the corrected version. I row in enumerate data selected equals 0. Still the same, I don't see anything corrected.
Just
What?
copy and paste it there.
What happened?
Forward button. You just click the forward button. The top. Yeah, the forward, not backward. Forward.
Gone.
Okay. Paste it again. Copy that pattern. Copy. Just copy.
I just want to see what was the difference.
Some code they have redefined. Some beta Bandit, some added new thing.
Def beta bandit data and comma machines.
Is it trying to, I mean, do we need an update or something?
Yeah.
Yes.
So
Import
explain error and maybe, yeah, just explain it and then.
it has actually explained.
Hmm.
You see, algorithm, here's the corrected version.
Okay.
Key fixes and the improvements made added proper function definition and parameters. Used enumerate to iterate over data rows. Properly initialized arrays for rewards and penalties. Fixed the total reward calculation. It was trying to add lists. So added proper return values, fixed indentation, removed unnecessary range,
Zero length data.
used more descriptive variables, variable names, max random instead of max random. Oh, I think it is almost similar. Just this piece is added.
Definition, diff
Here to
data
here it is
machines.
added. But in the previous this thing, it is there. Definition is not there. But you see, rewards 0 into machines, it is there. See. Penalties 0 into machines is also there. Yeah. Total underscore reward is equal to 0. This piece is also there.
For I own enumerate data. So that
This
is actually
not needed. No, this piece is not needed. Import random. We are already importing random here, which is also needed. Okay. Definition of beta underscore bandit data comma machines. That also
We have already, right?
yeah.
Emissions equal to 5, and then the rewards equal to 0 into missions. Penalties equal to 0 into missions.
So that is also there. So this piece is not needed. We'll have to see this. This is added actually. Enumerate brackets data, which is not there here. If you see, yeah, for I comma row in enumerate data.
Oh, okay. Here, enumerate, we have to see. You see the comment.
No,
Use enumerate data, not the above. Use enumerate data to iterate over the rows or the data. You see the comment. Use enumerate. So that enumerate actually they have implemented down.
that is replaced.
That's what
They have
row
used,
in enumerate.
yeah,
They have used it.
yeah. For n in range, they have used.
They removed actually the range here down. 0 length data they have removed. Instead, row in enumerate data directly used.
Directly used. Selected is equal to 0. Max random and
That is same. That is same.
yeah, same. Just this piece is changed here.
The range thing, I think they have removed using length data. Row selected. So just to run this part, remove that.
This piece we should remove. Okay, let us run this.
Okay. Just run it. It ran.
Good. So this piece we have to replace.
Just delete it.
Wait. Okay.
Delete that extra line.
It has used fourth machine. Now we need to understand what has happened here.
Just put the code.
So shall I go to Claude?
Yes.
Okay, they have fixed all this and changed. Then data is equal to 101. They are creating the data like machine is equal to 3. To use this function, it now takes data and number of machines as input, uses proper Python. This is the previous piece of code which we already have. See here. This piece.
We can remove that one.
No. Let me copy this. There is no difference.
What is the interpretation seen here?
Okay. Come to the which machine they have selected. Yeah, see.
Fourth
First
machine.
of all, in this medium article. Article. Come to the article.
Medium.
So it depends on the random selection process. Here it is actually, the third, it is getting some the total rewards, 195 total rewards. Actually, that mission is the third mission in this. I mean, as per this article and as per that data information, it has been selected for the third mission. So, in our information, it is getting into the fourth missions. Okay. The fourth mission is getting selected because that mission is getting more rewards. Did we get this kind of an output? Mission number 1 gained 0, 2 gained something.
No.
All right. Okay. Then where
Just got this output.
only
Because
this
our piece of code is changed, no?
Yeah, you have changed, right? Okay, so just keep as it is. One more, I mean, open the one more tab and try to run the entire code from that sample, I mean, medium.com. So that, we can compare where, how these guys are working. Because sometimes they do a lot of, we need to fix that.
Sorry, 1 minute.
So here the interpretation, how the mission has been selected, that is one thing. And because that mission is selected, and why that particular mission is selected, because that is getting more and more rewards. Very simple. So that means it is getting more positive responses. That is why this getting earning. It is earning reward points. So the people are, who are the user is just getting in, they are approaching. They select only that mission because that mission is getting more and more rewards, so that the user will get benefited at the end of the day. Just run this code. Okay. Now, yes. So the mission number 1. Okay, explain error. Name row is not defined.
It's not defined.
Yeah. So we need some kind of maybe it will just coming with something.
It's just a small. This we have defined row somewhere. 1 minute.
Yeah, here it is. For I, comma, row in enumerate. The 11th line. Yeah, 11th line for I, comma, row in enumerate data. So enumeration is also happening. So we need to know what is enumeration. That is also we need to get the definition of enumerate. So just ask Clara what is enumerate. What is enumerate?
Transforming
from
what is that? This one column to row to column.
Row to column, column to row. Okay, right? So it's a vice versa. Again, it is giving some with relevant to your previous question. Okay.
Let me explain
So is that,
examples. And built-in Python function that adds a counter to an iterable, like a list, tuple, or string, and returns it as an enumerate object. It's basically a way to get both the index position and
value
of items in a sequence at the same time.
Okay, now just imagine. So if it is getting 1, then it is ultimately moving to the third position. If it is, because the index starts from 0, 1, 2. If it is getting the number 2 mission, it's ultimately the third mission. Okay, so it just to go and adding the iterative process with respect to adding one more enumerate. The object. So if you see list tuple, it is working like anything. So again, you have to go back to understand the list, tuple, dictionary values, and where you will have the ability to change the value, or where you will be not able to change the value. That is also we have to know. That is, even all the functions will be doing or will be done along with enumerate function. So again, we need to the enumerate data. We need to learn more in Python, because it is not the machine learning algorithm, but this algorithm it is working from the random selection process. Okay. So while randomness it is getting into converted into too many things, then we need to go with the possibilities and probabilities. Okay. So first we need to understand random, we know that, and then we need to understand the range. They have given the range in the enumerate. So use enumerate function to iterate over the rows of the data. So each and every row, if it is getting run, it has to add penalties and rewards. That's it. Okay. So while doing this process, might be, it will be acting as a tuple, because in tuple only you cannot be able to edit. So there is no human intervention. There should not be human intervention. So the tuple is very safety because no modification has been done. So kind of a thing. So the rewards is getting added, and also penalty is getting added with respect to the number of iterations in the loop. That is why we are selecting a for loop in this range. Now just think, the rewards equal to 0 into machines. So that is the calculations. How
No, row is missing, no?
that's so used to enumerate and iterates.
It is directly using the enumerate function. How many ever times we give. But
Okay.
actually, in the whole code, if you see, there is something called row. Here they have defined row. Row is equal to row of 1.
Yeah. In our code, it is just a row in enumerate. Is there any other function?
No, there is no, what is that? In the first code, what we copied, no, there is row is not defined in for loop. We directly put it the range.
Okay. Row in something, right?
Piece is missing. This piece.
This piece, yes.
You go to that original Thompson code we copied. So here, there you can find it out. See, for n in range, right? So the row is not defined there.
For index, comma, row in enumerate. For j in range. This piece they are changing.
They have changed the entire thing. They have changed.
This piece. So let me copy this piece.
Just try, Sai, put a row in that for n row. Just put a row.
For index, comma, row in enumerate they are
Not
doing.
enumerate only. Just go to that previous code.
Here just I will put this piece.
So we have to define that in for loop. For n, no. For n comma row. We just mention for n comma row.
For n comma row. In enumerate they are saying.
We're just using the range. Just run it and see. Just execute. Now we define row in for loop.
Yeah, it is very error.
Use enumerate to iterate over the rows of data.
Okay. So enumerate has to be the range. We have to remove the range, use the enumerate.
This piece we have to use, that's what. Yeah.
Yes.
Yeah, it executed. Oh.
Yeah, see?
Yeah.
I think the entire code has run. Yeah, now you got everything. Okay. So since we are choosing the random, even for Sendil, he will be running, he will be getting the different result. And you are running, you will be getting the different. And I will be running, I will be getting the different results. So it won't match always.
Here first machine total got 51 reward.
Mission number 2 gained 3. So the mission number 1. Yeah. So it has got more rewards. So that machine will be selected. Yeah. So there is some, okay, deprecated in the future. Okay, that is a note from my Python. So now, yeah, this is where, so while even you can just do the, instead of histogram, you can go for the heat maps and other, you know, so that, it will be really, the heat maps is really, will be helpful in those kind of things. So that is also
So
will be.
here we should change, right? Plot.
Yes, yes. You have to change the plot. Instead of plot, you can just go for the heat maps. So you can get the code, that anywhere. So you can plot or whatever.
Hmm.
Even you can ask just plot how to get the
Same.
heat maps instead of plots. Yeah.
Just copy that code. Put. Can you give it me in the for the heat map? Yeah.
One thing I understood, if you continuously chat, it's like a chat only. Same code, it will.
We give you the image.
So this version creates two heat maps. Win rates heat map shows the success rate of each machine over time. Selection frequency heat map shows how often each machine was selected in each time window. Features of uses a color gradient yellow to red to represent values. Okay, first let us run this code.
Save all the code. Save this. The untitled key. Just name it into give a name. Yeah.
Thompson histogram.
So it is doing same. Seaborn is added.
Just to say, under come down.
Too many sessions.
The plot.
Yes, you have to close the rest of the code.
Come down just to see the plot area, which graph they are using. Frequency heat map.
Subplot they have used. SNS.heatmap. Both the plots SNS.heatmap only.
Okay.
Total place 4, machine to oh.
Yeah, it's really giving very nice information.
Oh, the program workers, no, nothing, Sini. Just everything, this only giving, yeah, all the programs. There is no job for the program. Just to give the instruction,
Yes,
it will automatically
that is
generate.
why. So very soon, all the SAS programming works will be done by agents. That is called the AI. Okay. Soon, so better you are just, as soon as possible, move into AI along with SAS or along with any techniques. Yeah. So you will
So
just use that.
this is the slot machine data, correct?
Yes, yes.
So each machine, how many times?
The iterative during the iteration process, how many times it is getting recorded the value, whether it is a penalty or a reward. So it is giving us detailed information. That is why the code has been entirely changed after some point. and it is just getting through heat map. So that is why always heat
That
maps
is
will be
the win rates over time, which means
This is
like
a reward.
time window is like what is the time window like? 1
hour, 2 hour, 3 hours,
Oh, okay. Hours,
Yeah.
okay.
20
Time
hours.
window till 20 hours they are taken. And, yeah. So even
So
you
what is
can
the time difference like color coding difference? Like very dark color it indicates like
just go
Heat
go up.
maps.
They have
Those
that's
number
what
only, highest number will be darker.
you can go to the upper. They have a data. Yes, this one. Just read
that's
this
what I want to
statistics.
see.
Yeah, summary statistics. Mission
So
one.
machine total plays 4, wins 0, losses 4, overall win rate 0.
0.
Machine 2 total plays 31, wins 15 times, loses 16 times, overall win rate 48.
Just check the data. Machine 2. Just check the statistics over there. Total plays 31, wins 15.
Losses 16. So, but here only 20 are there, no?
Yeah, we will do number of selections and times as a time window.
34 times.
Machine 2 wins 15 times.
Just check
This
how
is
many times it is getting
percentage.
recorded. Yes.
Percentage of win rate.
Win
It's
rates
over
over
time.
time.
So time here.
Here in this, if you see, for example, in the second hour, 2 o'clock or whatever time, if you see, 100% winning rate, machine 2. 30% winning rate for first hour.
So
60% winning rate for 8th hour. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 times in 20 hours, 10 times winning percentage has been shown. But actually it is like 31 wins. Total plays 31.
over 24 hours, you just assume. So
Yeah, over 24 hours.
So you have to take it for the rest of it because they are just showing with the 20 hours. You have
Total
to
plays 31 times.
So can we go up and see the code once?
So everywhere, you can, if you can use the heat map, you will get into a different idea. Okay, so don't forget to, don't avoid to code this heat map. Going forward, you have to see because in deep learning, you have to
Split the time windows 20 to 21 row line you can come. Time window equal to 20. Split the 200 trials into 20 windows. 200 trials into 20 windows. That means 21st line. Come to the 21st line.
1 minute. I'm just saving this code and keeping. Yeah. So 21st line. Yeah. Times window. You can just make it 35.
No, here split the 200 trials into 20 windows. They're splitting. See, 200 trials we given range, we given try 200.
Means
So
each window is 10.
10. Yes.
Each window is 10 trials.
10 trials.
So that means here
one is the success. One is the success, right?
Yeah. No. Percentage of success. Here, first 10 slots. Out of 10 slots, 3 slots are winning percentage. You count now. First one, 3. Second, 10.
13.
Plus 6.
19.
5.
24, 29.
plus 5.
29.
No, these are percentages. See, 31 games they have played. Machine. Okay.
Mm.
Win percentage is 50%. That means here every slot, like out of 10, uh, 3 games might have been won.
0.33. 10 trials. 200 trials split into 20 windows. Okay, 20 windows is there, 200 trials. So each time window has the 10 trials. Mhm.
That means out
Okay.
of 10 games, 3 games have been won. No. Wrong. Out of 10 games, 3 games means it is 30%. Hmm. 0.33. Correct. 3 games might have been won. This is percentage of winning only, no? Time window over win rates. Yeah, win rate is nothing but percentage. Correct. So 30% of winning here. 100% winning in these 10 games. That means out of 10 games played here, all 10 were won.
Mm.
Then these slots 0, 0, 0, 0. Then here out of 10 games played, 6 games were won.
Yeah,
Here 50-50.
29. 3, 10, 13, 19, 24, 29. 29, 6, 35, 30, 45, 45, 49, 54, 54, 57.
It will not match until 57 means machine 2
Mm.
total place is 31 only.
Total place 31.
But how much you are getting?
54.
52 you will get.
54. Yeah, 54. So maybe our understanding might be wrong. Machine, come down, come down, come down. This is number of selection over time. Okay, this is 2 different windows. The first one is winning rates over win percentage, win rates over time. Just ask them how to interpret win rates over time. That particular, how to interpret win rates over time in heat map. In above heat map, yeah.
I think they have given some information before. So okay, just.
Is the detailed interpretation. Row x-axis.
So if you take a small example.
Mm.
So you can go very small. So you can just,
Just go back. Yeah. Back.
Why is it disappearing like that? Oh,
I click that, yes. The first one.
this one?
This is, yes, this one, right?
No, you have to write it. How to interpret it. You have to.
Okay.
Yeah, here. How to,
Yes.
Let me explain
win rates.
Win rates. So win rates I comma j performance underscore matrix I comma j by selection matrix I comma j. Here's the detailed interpretation rate. Structure of the heat map rows y-axis. Each row represents a machine 1 to 5. So
Y-axis.
here 1, 2, 3, 4, 5. Okay.
Y-axis, correct.
Column X, each column represents a time window 1 to 20.
Mm.
This is 1 to 20.
Mm.
Color intensity darker red to yellow.
Yellow,
It's higher.
higher win rates. So yellow and darker have higher win rates.
No. Yellow is the least. Darker red is the highest.
Go to the color code.
See.
3 colors are there, no?
That's
Red,
what. Here,
red.
right side, you can see the map right here. It starts from 0 to 1. Here, if you see. Sorry. Can you see here my mouse?
Yeah.
So this is what they are saying. It starts, so yellow is the least, red is the highest. Yeah, win rates. So numbers in cells, actual win rate 0 to 1. Oh, okay. How to read the values? 0.00 is equal to 0% win rate. Machine never won in that window. As we discussed, it was correct only. In this particular window,
Machine never win.
Yeah, out of 10 games, this machine never won in this time slot.
You
understood?
Correct.
So that was correct. Our interpretive understanding was correct. 0.50 win rate, machine won half the time. Half the time in the sense, out of 10, for example, if you take third hour, in this hour, machine 2, if you take machine 2, in the second hour, it has won 100% of the time. That means all 10 games it has won. One means 100% win rate. Machine won every time. So, machine 3, 0.80, 0.75, this machine consistently perform well. Increasing values over time. Okay. Oh, we have to see this way. Okay. 0.8, 0.75, 0.85, 0.78. But I don't see, okay, 0.8. There is no 0.75 only.
But increasing consistency, you see, it's like 0.80, 0.671, machine 3.
There, it might be different. Here we are getting 3, machine 4, machine 5. Machine 5 is consistently performing well here in our system. So 0.75, 0.80, 0.80, 0.67, 0.67, 0.71, 0.60. And 100% also is there. So majority of the time, machine 5 winning rate is more. So yes, that is correct. See, out of
53% overall win rate.
Overall win rate is 53%.
53%.
So here, the number of percentage of win rates throughout the map, if you see,
Heat map, that means darker side is more.
Yes. Machine 5 is performing well. So let me create a small example to illustrate. So they have created example win rates is equal to array they are creating. Machine 1 consistently good. Machine 2 improving over time. Machine 3 stable average. Machine 4 degrading over time. Machine 5 inconsistent or rarely selected.
That's the reason the percentage they given, the overall statistics in our data. So that win rates over time, the percentage they given, so that we can easily identify, okay, that percentage time machine win over the time.
No, this is the example they are creating, sir.
No. I'm talking about our code. You just go to our code. There is a statistics given. Go up. Overall win rate. So from this only we can easily understand overall win rate. So machine 5 is 53.1. That means the chance of that mean you getting that output, the winning rate, no, that is getting increasing. So from overall win rate also we can easily understand. Okay, this is summary statistics. Okay, this machine has 5 has the good winning rate. This machine, yeah.
So then they are plotting heat map here. Okay, key pattern to look for: horizontal pattern show machine consistency, vertical pattern show time window performance, color gradient show relative performance, empty or zero cells show exploration patterns. Okay, shall we run this? Create here they are creating the example data. Here is they have given, they are creating the heat map. Okay.
So generally heat map used to differentiate like over the time. So anything which is over period of time that we can easily interpret it through heat map, right, Sini?
Yes.
Here sent what color coding. That is what they are showing here. 0.8%, 0.7, 0.9, 0.85, 0.95. So here how it looks. Machine 5 is the least performing machine, is what they created. See, inconsistent or rarely selected.
First one is consistently good. Machine 1 is consistently good.
So they have created the data like this for
Okay.
explanation. Okay. So yeah, okay. Horizontal pattern shows machine consistency. See, this pattern shows machine's consistency. Vertical pattern shows time window performance. In this time, which machine is performing in this time slot, in which machine is performing well, that is what we can know. And yeah, color selective show relative performance. Exploration, okay. Common interpretations. Common interpretation, high value consistency in one row. Oh, this is just a likely the best performing machine. High values consistently in one row. Gradual increase in values. Okay, this is the code. These are just comments, right?
Comments.
Yeah. Common interpretation, yes.
Questions to ask when analyzing. When machine has the most consistent, which machine has the most consistent high performance? How long does it take the algorithm to find good machines? Are there any machines that are completely ignored? Does the algorithm converge on specific machines?
So now below they have given the real world application.
Best machine is equal to NP argmax win rates dot axis 1. But where is the data? Same data it will take from what we have done.
Maybe just apply.
Real world application. Down, yeah. Win rates is not defined. Win rates.
It is not a combination.
Oh, yeah. Just an example. Different. That is different. This is different.
Just an example, yeah.
Yes.
Okay.
Okay,
Great.
now it is clear like how.
Yeah. Only thing is we just know how to interpret. Yeah.
Yes. So that's why, in the initial days, I used to say the heat maps, learning heat maps, and interpreting heat maps, that we need to have some practice. Okay, so what is the, yeah, so do you have any questions in this algorithm?
No, Sini.
What is the next algorithm?
No, only two things are there. So we'll move into other one.
Okay.
Next class.
Okay. What is that? I just
What is that? Let me open that.
Natural language processing.
Okay. Okay. So hereafter we have to go in a different path. Okay.
Oh, this is different, completely.
Yeah, completely. Before that, we have to see the artificial neural network, and then only we have to come back. Yeah.
Okay.
First we have to see what is artificial neural network, and then we have to see convolutional neural network. In that convolutional neural network, NLP is a concept.
Oh, okay.
So we have to see before even starting the ANN, I mean artificial neural network, we have to study about the neural network. Yeah, that is a big topic. So we have to spend at least 2 to 3 hours for all the theoretical knowledge. What is neural network, and how the knowledge? Just note it down. What is knowledge base? What is knowledge base? Getting that. First of all, what is knowledge base, and then
Where is my notes?
what is knowledge base? Now hereafter, you have to think in a different way, and we'll be seeing a lot of theory, and that theory will support your process of implementation.
What is knowledge base in neural network?
Just common yes, neural network or machine learning and deep learning. It is a very generic term, and then we will be coming into the deep learning. Okay, so what is knowledge base in neural network? That is one. The second one is knowledge repository. Knowledge base, knowledge repository. It seems that to be look like a similar thing, but it has slight difference. It's anyway we have to discuss knowledge repository.
What is knowledge repository? Okay.
Yes. And then what is neural network? What is neural network? So we are stepping into the deep learning module. From next class onwards, we are into deep learning module. So what is neural network? Yeah, that's it. In these three things itself, it will take quite amount of time.
Okay.
We'll be discussing a lot of things like neurons, how how memory has been, you are getting association rule learning. All these things will be getting into the respect to neural network, how does it work, and how does it just getting associated, and how are you getting reminded of things, and how it is, where it is getting stored first. And then only you'll be able to interpret something, right? So if you are talking about any instances in your life, immediately you'll be relating to something else. So where it is coming from in your neurons, where it is getting stored. If it is getting stored, are you thinking of always about those kind of instances? No, never. If you think always, we'll be getting high pressure. That is why, in your office, if there is an issue, you'll be thinking aloud. So that is why your pressure is coming up or going up. Okay. That is also a kind of a pressure. So how this neural network is giving you this kind of information, first of all. Okay. So we need to discuss in a broader aspects. It is and moreover psychology. Just please note it down. Psychology. We have to discuss about the psychology too. Psychology of human being. In this neural network, we have to discuss about psychology. So mostly, so you will be getting into the psychology. Yeah.
Psychology. Yeah.
What is psychology?
Yes, psychology.
Psychology of neural network.
Yeah, psychology of neural network. Psychology of first we have to understand the psychology of human being, and then only you will be able to understand the neural networks. So it is like, I mean, when you started learning AI/ML, it is like you are studying yourself. Okay, so it will just open up a lot of windows hereafter. And then we are going to, putting up a model. A lot of models we are going to learn, and hereafter the model, I think some of the codes will run in your computer. Some codes will not run because of infrastructure issues. So we'll see. We'll see whatever the limitations, whatever the advantages. Based on that, we'll take out the code samples and then we'll go. Okay, thank you. Any questions? Okay.
No, Sini.
Okay. So this Saturday, Sunday, because I'm just here, I will be closing the sessions on Friday, and I have to start on Saturday. I'll be most of the time I will be traveling to Chennai. So maybe if you have time tomorrow and day after, we will close it for this Saturday and Sunday.
No. Tomorrow I have an event at home.
Okay.
Mom is doing a puja. I am already on leave.
Okay.
Friday, if you want, we can do.
No, Friday, I'm just, I'm leaving.
Okay.
Because here nearby.
Next Monday we can see Sini. Next Monday.
Yes. Next Monday.
Okay, next Monday and Tuesday we'll see.
Monday, Tuesday, I'm fine. Yes.
Okay.
Next Monday, because Saturday, Sunday, if you are traveling, so we can book it into Monday.
Okay.
Next Monday. Okay, next Monday and Tuesday, same time, same thing we can continue.
Right.
Okay.
Yeah, 28th and 29th next class. Yeah.
Yeah.
Sure.
Okay.
So yeah, thank you so much.
Okay, Sini. Yeah. Have a great. You just share that video that we will download it yesterday and today.
Yes. Yeah, I will do it.
Okay. Thank you, Sini. Yeah.
Thank you.